Welcome to this presentation, Revit Project Export from Inventor for BIM Collaboration. You're here today because you're a Revit user working with data from Inventor, or you're an Inventor user working with data from Revit. And you may have struggled in the past to coordinate the design of your projects using 2D data, so you're looking for a better way to collaborate with your manufacturing and construction colleagues using your 3D models to ensure that clashes and sequencing issues are discovered and dealt with in the design office, instead of on the construction side. My name is Paul Munford. I'm an industry marketing manager with Autodesk Design and Manufacturing. In my previous life, I was a draftsman, creating manufacturing drawings on construction projects, and so I've been that guy trying to understand and coordinate details from 2D drawings, and often having to go to site to help correct problems that we just didn't foresee. Back when I was a drafter, I wished that we could share our 3D data for better collaboration, so I'm really excited to share this new workflow for Inventor and Revit Data Exchange with you today. Above all, I hope you'll leave this presentation with the enthusiasm and confidence that you need to try out this new workflow and figure out how to make it successful for you. In today's class, our learning objectives are: we'll learn how to simplify an Inventor model in preparation for exporting to Revit. We'll learn how to export our Inventor model as a native Revit file. We'll learn how to link our Inventor file into Revit, and we'll learn how we can update the Inventor model and also update the Revit export. Now, this Autodesk University class is an opportunity for you to try out the workflow in the software for yourself. To go with this presentation, there's a dataset for you to download and a handout which has step-by-step instructions for each exercise. You can download the handout and dataset from the AU Online class page, or by following this link. At Autodesk University Live, a lab-style class is an opportunity to get hands-on with Autodesk software. The lab instructor takes you through the exercises, and there are lab assistants to help you if you get stuck. Due to the coronavirus pandemic, AU is entirely virtual this year, and this means you'll have to work a little harder to get the best out of this class. You'll need to install the software yourself, download the handout and dataset, and follow the instructions with only a little help from me, but no lab assistance. I've tried to make the instructions for each exercise as straightforward and easy to follow as possible, and I welcome any feedback you have for me so I can improve this for you. Okay, before we get into the exercises, let's just take a few minutes to understand why this topic is so important. Buildings are built from components that are made by manufacturers. So there is no escaping the role of manufacturers in the construction industry, from the processing and manufacturing of building materials to building products and equipment and specialist construction systems. One industry could not exist without the other. The construction industry does have a poor reputation for efficiency and productivity, but it's looking to manufacturing for guidance on optimizing and automating how we make buildings. The worlds of manufacturing and construction are rapidly converging, and it's more important than ever that the tools we use to design and make our products help us to collaborate effectively. One of the biggest problems facing building product manufacturers and contractors in the AEC industry is coordination and rework. Often our profit margin is linked to the final payment, which is only received once our products are installed, commissioned, and signed off. And this can't happen if we deliver our product to site only to find that it doesn't fit, or there's an installation sequencing issue. So in this class, we're going to learn about new functionality released with Autodesk Inventor 2022 that allows us to export a native Revit project from Autodesk Inventor, and we'll recap on the functionality introduced with Inventor 2021 that allowed us to reference a Revit project file into Autodesk Inventor to use in coordinating our designs with the collaborative 3D design model, or BIM. In Inventor 2021, we introduced Inventor AnyCAD support for Revit project files. AnyCAD allows Inventor to reference a CAD file for many different authoring applications, including Revit. The CAD files can be edited in their original authoring tool. When the files are saved, the referenced model will update inside Autodesk Inventor. And referencing a Revit project into Inventor helps us to coordinate our model and make sure we have everything in the right place. With Autodesk Inventor 2022, we've added the ability to complete the round trip of the design by exporting a native Revit RVT or project file from Inventor, which can then be linked into Revit for coordination. Let's take a look at how this might work in the context of an AEC project. So we're going to imagine that we're working on a project and it's our job to coordinate the factory line equipment with the building design. Perhaps we're an engineering service provider who's responsible for specifying the equipment. Perhaps we work for different departments in the same company and we want to make sure that our work is coordinated. So we'll start by referencing the Revit model into Inventor, and then we'll use the Revit model to coordinate the placement of our manufacturing equipment. Next, we'll export our Inventor model as a Revit project, and we'll see how we can link the model into Revit for coordination and review. And finally, we'll see how we can use the Inventor model as a reference inside Revit and make a change to the Revit model accordingly. So I'll demonstrate this workflow to you during this video. Given the class length, I can't take you through every step in the workflow in as much detail as I would like, so I've created separate videos for each step that you'll find in the zipped folder within the dataset. Each exercise is standalone, you can work through from start to finish, or you can pick out just the steps that are most interesting to you. After watching this overview presentation, you can watch each exercise video, then pause the video and use the dataset along with the step-by-step instructions in the handout to try the workflow out for yourself, or rewind the video and follow along. I've supplied a dataset with files for each exercise. If you don't get the results you're expecting during an exercise, don't worry. Just close the file you're working on and open the file from the folder in the next exercise. Before we begin the class, please make sure you have the following: Inventor 2022 installed, including the Revit interoperability hotfix, and there's instructions on how to get hold of this in the handout. Revit 2022 installed. The dataset downloaded and extracted to your C drive. A copy of the handout and this video of the presentation. One more step in preparation for this class, we need to set the Inventor project file, which lets Inventor know where to look for the files in this class. So you'll need to navigate to the Get Started tab, Launch Panel, Projects button, and in the Projects dialog, click Browse. Navigate to the location of the dataset for this class, select IM5-00008 IPJ and click Open. And you'll know if you got this step right because you'll see the class project is set current in the project browser and it has a check or tick mark next to it. Let's start here in Revit. Here is the complete building that we'll be working in. We can also see a view of the area of the model where we'll be placing our equipment. We'll come back to this later. The Revit modeler has created a view of the model which isolates just the area we'll be working on in Inventor. This is helpful because it will reduce the load on Inventor while we work on the design. The Revit project file can be shared with us simply as a file, or it can be managed with Autodesk Vault, or coordinated via BIM 360 Docs. Let's move across into Inventor. We can start with a blank Inventor assembly file, and we'll reference in the Revit model. We'll go up to the ribbon menu and look on the Assemble tab for the Place tool. We'll pick on the drop-down and choose Place Imported CAD File. We can now browse to the Revit project file that we wish to reference into Inventor. As the Inventor AnyCAD dialog opens, we'll notice we have the option to filter out any Revit categories that we don't want to bring through into Inventor. We'll also be presented with a list of saved views that are available within the Revit project. We'll pick Production B Coordination from the list and click OK. The Revit project is inserted into the Inventor assembly file just like any other component. We want to make sure that the coordinates of the Revit project match the coordinates in Inventor. So we'll right-click and choose Place Grounded at Origin. If we move our attention over to the browser, we'll see that the inserted Revit model has a small blue arrow icon. This indicates that the Revit model has been linked into this Inventor assembly using AnyCAD. If the Revit file is updated, the referenced Revit file will update inside Inventor. We'll see how that works later in the demo. As we browse the model tree, we'll see how the Revit model is categorized, and we can drill down to the elements we're interested in. We can also select individual parts in the model and find them in the Revit category folder in the browser. Our next job is to place the inventor model of our production line machinery into the design. To save us some time, I've already placed the models and hidden them from view, so let's make them visible. And of course, we could place relationships between the inventor model and the Revit model, constraints, work features, sketches with projected geometry, confident that should the Revit model update, the AnyCAD reference here inside Inventor will update as well. Let's zoom in on our model, and we have a constraint we can drive over here. I'm sure you've already noticed, in the process of modeling our design, we've identified a clash. Now we could of course move the jib crane to another location, but let's imagine there's a good reason that the jib crane is where it is, and in fact, we're going to have to move the overhead ducting instead. So, how could we collaborate on this clash? Well, we could create a couple of screenshots and mark them up, or we could create a drawing of the area with some dimensions on it, or we could open our Inventor model in Navisworks and coordinate that way. But we're going to see how we can export our Inventor model as a Revit project, which can then be coordinated directly inside Revit. Before we export the model, let's switch views again. In this view, I filtered out people and vehicles, anything we don't need to bring through into Revit. And we also want to make the reference to Revit model invisible because we don't want to round trip that back into Revit. We may want to simplify our Inventor model further. Typically, we'll model our designs in Inventor at a scale of 1:1 with every nut, bolt and washer present. And this is way more detail than is needed for coordination on a BIM project. Our Simplify toolset is incorporated into the Revit export command. So let's go to the File menu, the Export Flyout, Revit RVT. And we'll scroll down to the bottom of the dialog to look at the export options. We'll see that the file type is set to Revit RVT, and we can choose a file name and a save location here. Below this, there's the option to set the Revit BOM structure. This setting is relevant to the ability to tag and schedule the components in our design once our model ends up inside Revit. All in one element means that our Inventor model would appear inside Revit as one lump. Each top-level component means that our Inventor model would appear inside Revit as individual components that can be tagged and scheduled independently. Now let's go back to simplifying the geometry of our model. Up at the top of the dialog here is the option to replace our model components with envelopes. We can choose to export one big bounding box that incorporates all of our model, or we could choose to export each top-level component as a bounding box, or we can choose to export every part as a bounding box. Rather than simple bounding boxes, we can use the controls below to remove detail with greater precision. We can choose to remove components by size, or even remove individual features. We could choose to remove all holes, for example, or all fillets, and we can filter our selection by size, or even preserve features that we don't want to be removed to make sure they're available for coordination. So, at the beginning of a project, when you're just space planning, the top-level bounding box for each component might be all that's needed. As the project progresses, you can choose progressively finer amounts of detail to include in your model, depending on the requirements in the BIM execution plan. At the top of the dialog, we have our presets. This allows us to save the selections we've made in the Simplify and Export dialog, allowing us to reuse the same settings across multiple designs, or even standardize our export settings per project or company-wide. Now I'd like to show you a different method of simplifying our model. Rather than using the top-down approach, simplifying our model after it's complete, we're going to show a bottom-up approach, designing our simplified state into our model as we go along. In this example, I've used model states in Inventor to create a simplified version of each component, which can be triggered from the top-level assembly. This allows the finest possible control over which features are exported to Revit and allows support for the inclusion of additional features, such as exclusion zone geometry. So we've set our output options, our BOM structure, and simplified the geometry, and we're ready to click OK and export our Revit file. Our Revit project file is now being generated, but before we take a look at it inside Revit, let's just take a quick look at the Inventor browser. You should now see a new Revit Exports folder has been added to the model browser, containing a node that represents our Revit export. If we go up here and right-click on the Revit export, we'll see we have a couple of options. Update allows us to re-export an updated Revit file from this model using exactly the same Simplify settings. Edit Simplify allows us to change the Simplify settings we chose last time before then outputting our updated Revit model. Both options will overwrite the existing Revit file, which can then be updated inside Revit. If we produce multiple Revit exports from our model using different file names, we'll see multiple nodes in this browser folder. This could be useful if you need to send out different versions of your design with different detail levels or different configurations. Okay, let's jump across into Revit and we'll see how we bring in our Inventor design. Here we are back in Revit. We want to see what happens when we bring our Inventor file into Revit as a Revit project, and we'll do that using something called linking. So we'll go up here to the Insert tab and we'll look on the Link panel for the Link Revit command. And we'll click on Link Revit and we can browse to the Revit project file that we exported out to Inventor. We'll select the file and pick Open. And because we created this model in Inventor using the Revit model as a reference, you can see the coordinate system of the two models line up perfectly. This allows us to coordinate our design in Revit and examine it against the original design model. All the models of the other trade contractors are also going through the same coordination process. So, here is the clash we identified inside Inventor. Let's see how we can fix it inside Revit. Let's take a look at our 3D view and 2D reflective ceiling plan side by side. And we can select here the duct we want to move, and we'll see it highlight in our model in both windows. I'll select the dimension it needs to change and type in a new figure. And we can see that the duct has moved and it no longer looks like it's causing a clash. Now, we want to be able to round trip this back into Inventor. And to do that, we'll save the Revit model. And back in Inventor, we'll see a lightning symbol next to our reference Revit model. And we'll also see the update button is highlighted. It looks like a lightning symbol over a piece of paper. And that's because of the Anycad system, meaning that when the Revit file was saved, it's triggered this update inside Inventor. So we'll click on the update button to receive the update, and we'll see whether the clash has been resolved. So the update is done. Let's swing the jib crane round again and check that we have clearance, and that looks good. So the clash is resolved, and we're ready to move on to our next task. Many Autodesk customers manufacture components that will end up inside buildings. We're working hard to bridge the gap between manufacturing and construction to help you design and coordinate your workflow productively and efficiently. So, to recap, we've brought a Revit model into Inventor and used it as a design reference for laying out the machinery in our facility. We now have everything we need to procure or manufacture the equipment in our process line. But before we do that, we still need to go through the coordination and approval process. One advantage of the BIM workflow is that we exchanged the 3D model rather than just 2D drawings. And thinking about our customer for this model, in this case the building design team, we simplified the design to show just the level of detail that's appropriate for this stage of coordination. We were then able to bring the Inventor model into Revit, check the design for fit and sequencing, and make any necessary changes to the building model to ensure the design is coordinated and ready to be released for construction. Finally, we saw how to update the exported Revit model from inside Inventor so we can be reassured that the coordination has been done and we can move on to the next task in our project. Inventor 2022 can export files for BIM coordination as an RVT, that's a Revit project file, or an RFA, that's a Revit family file, and also an IFC, which is a neutral BIM file format. The Autodesk Product Design and Manufacturing Collection also includes Navisworks, which is often used in the AEC industry as an on-premise coordination tool. So if you're required to supply a Navisworks file, that will be an NWD or an NWC as a project deliverable, it's as simple as opening the Inventor file Navisworks, saving the file, and issuing the Navisworks file for coordination. Your RVT, IFC, or Navisworks file can be managed locally with Autodesk Vault and manually uploaded, or automatically synced to Autodesk Construction Cloud, which provides online BIM coordination and review tools. What we've discussed here today is a very specific workflow between Autodesk Inventor and Revit, and obviously there's much more to building component manufacture than coordinating the design. What we haven't had time to talk about is Autodesk Inventor as part of the Product Design and Manufacturing Collection, helping you with the end-to-end workflow from initial concept design through to the manufactured product, supported by data management in Autodesk Vault and process management in Fusion 360 Manage. The collection includes the design and automation tools in Inventor, plus advanced simulation for testing your designs, nesting, and 2.5 to 5 axis CAM for manufacturing output, and factory layout tools to help you optimize your production facility. It's an end-to-end solution that works right inside Inventor and includes complementary tools like AutoCAD, Fusion 360, and Vault. I'm going to close with a story about my friend Tim. Tim was the workshop manager when I went for my very first job as a draftsman in the construction industry. And Tim taught me what I really needed to put on drawings so the manufacturing team could produce the products our customers had ordered. Now it turns out that Tim had also been a draftsman, but he hadn't managed to make that leap to the computer. So one evening, I grabbed a 6-pack of beers and the install discs for AutoCAD, and I went to Tim's house and we installed AutoCAD on his wife's cranky old desktop PC, and we had a few beers and we had a lesson and we had a laugh. And a year or so later, when I left that position, who should take over my job as draftsman but Tim? And in fact, he went on to have a very successful career as a draftsman using the computer. Now, I can't take too much credit. He was very intelligent. He was very experienced. He just didn't have the confidence to make that leap to using computer-aided design. And that's what I really want you to get from this class. I hope I've given you everything you need, a data set, a handout, some videos to try out this workflow. But more than anything, I hope that you've got the confidence to try this out, because if you don't try it out, you'll never learn it. So my challenge to you, as soon as this presentation's finished, take the data set, take the handout, watch the videos, try this out for yourself, and figure out how to make it successful for you and your company. Thank you very much.